Welcome to DigiDemo and the Internet of Things, the first in a series of 2 educational e-learning elements which constitutes a framework for learning activities in the contemporary industrial world. But first, DigiDemo is a project funded by the EU through the Erasmus Programme. Participants in the international group are Fachhochschule Vorarlberg from Austria, Este Belfort, based in France, the Central University UBB Resite in Romania, and Viken Higher Vocational College based in Norway. The lead applicant and coordinator of the project is University College of Northern Denmark. IoT is short for Internet of Things, and is a concept that all the things around us can be connected to the internet. This enables us to remotely control the things and collect data in a way that previously was impossible. With IoT, we can enhance products, make work and business processes more efficient, reduce costs, and create new digital services. Thus, our products and services increase in quality and the businesses become more profitable. IoT is a central part of Industry 4.0 and boosts the trend towards automation and data exchange in manufacturing. It is also an important tool for sustainability in products and processes. In this video, we present tools for learning IoT and how it can be implemented in products and creating new services. Through IoT, modern manufacturing is highly interconnected, monitored, and autonomous. We collect data to predict maintenance needs and learn about the process's pros and cons. In this way, we can improve our facilities. Our products become smarter, enabling us to increase quality and launch new services, such as smart homes. The introduction of IoT in products and processes demands new skills and a holistic approach to development requiring interdisciplinary competence. The DigiDemo-Project has developed 20 demonstrators to be used in practical and experiential learning activities in higher education that aim to teach IoT. This first video will present one of the demonstrators and how it is used by the students to acquire IoT knowledge. The second video will present the generic demonstrator framework and how it is applied on the demonstrator presented here. The case in question for our demonstrator addresses a problem with dangerous amounts of snow amassing on the roof of Norway's holiday homes. Many families have cottages in the mountains for relaxation and as a point of departure for skiing in the winter. Most of the time, the buildings are remote, and the snow may amass to dangerously high levels. The demonstrator is based on a product and integrated service developed by a small startup company named Nisni. The question was, how can we monitor the snow depth on the roofs and warn the owners of imminent dangers due to high snow loads that may cause structural damages to the building? To answer the question, we face some challenges. Many of the cabins do not have electricity, so how can we overcome that? They often do not have Wi-Fi. Can GSM communication be a solution? Snow is not just snow. There's a reason for the Inuits' more than 50 different terms describing snow. How can we make good measurements under all conditions? Moreover, we must also consider various aspects associated to sustainability. For example, how to maintain, repair, reuse, or eventually how to recycle the product.
From my point of view, there are 3 important factors in a good lab demonstrator that supports the students' learning. First, it must have the technical content the curriculum require. Secondly, the demonstrator itself must have a real-world relevance, and it must be a product that the students can relate to. And third, it must have a challenge the students feel they can solve. In the task on this demonstrator, the students have done the programming and the setup of the services that support the product.
I feel that I've learned a lot from the demonstrator. The most important thing is that we have free hands to analyze, plan, and organize how to solve the task.
It's also very good to know that the task we worked on makes sense, that someone can actually use the final product.
This image shows the architecture of the solution for the snow depth measurement demonstrator. A laser distance sensor from Garmin, named LiDAR Lite version 3, is used to measure the snow depth. The LiDAR will provide valid measurements from different kinds of snow qualities. The sensor is connected to an Arduino MKR 1400 GSM controller module. The microcontroller will gather sensor data and distribute the measured values using the MQTT protocol. The program running on the microcontroller will be shared and documented to enable students to make their own adjustments and to understand how it works. GPRS will be used on the microcontroller to provide connectivity. The MQTT protocol defines the message structure and format, and the data will be carried by the TCP/IP protocol. In the cloud layer, two different software packages will be used. The Mosquito software will provide an MQTT broker service to manage the data messages and distribution, and Node-RED will receive information, process it, and display the information to the user in the application layer. The image shows the demonstrator with the LiDAR sensor and Arduino controller with GSM communication. Note the cable to the external antenna and the connected LiPo battery. The twin transition of sustainability and digitalization are addressed in the demonstrator. Firstly, the demonstrator will contribute to quality education. Secondly, affordable and clean energy is addressed through software-controlled energy management, ensuring minimal consumption of energy. This is also supplemented by the application of a solar panel for battery charging. Thirdly, the demonstrator will contribute to building competence in IoT, supporting sustainable development in industry, innovation, and infrastructure. For more demonstrators, access the DigiDemo homepage, www.digidemo-project.eu. This concludes the introduction to the DigiDemo demonstrator. After you have finished this video, take some time to reflect upon and suggest answers to these questions. 1. How can you incorporate interdisciplinary learning in your IoT training? 2. Are business cases a natural part of your IoT curriculum? And 3. Is experiential learning through practical demonstrators relevant in your IoT, product design, and manufacturing training programs? The next video in this series will be about the framework of the DigiDemo series of pedagogical demonstrators for IoT training.